then we'll kind of refresh back into there. All right. So finding the domain. Now, there's a lot of different ways we could go about this. I think the main idea is when finding the domain, there's one thing is you want to make sure you can identify the domain of square roots, and then also how to identify the domain of composite functions. So the first thing is let's find the domain of f of x and g of x just separately. Let's just kind of cover that. So remember, when we're looking into the domain, we're basically looking for what are the values where the x is going to be undefined. Like what are the values of x you cannot plug in, right? And so we see if we plug in 1, we get 0. Square root of 0 is fine. But any number like 1 or 2, 3, that's going to make our radicand, what's our expression under the radical, negative. So like number 5, for instance, 1 minus 5 is negative 4. You can't take the square root of negative 4. So the process we're going to do is set our radicand greater than or equal to 0, because radicand, whatever taking the even root of the square root, has to be greater than or equal to 0. And therefore, I can now just add an x here. And therefore, 1 has to be greater than or equal to x. So x, has to be less than or equal to 1, which makes sense. Then I'll go ahead and do g of x, and we'll do the same thing. But this one is going to have a different, obviously, domain, because 1 actually doesn't work. But you can see 4, which didn't work here, works here, right? 4 minus 3 is 1. Square root of 1 is 1. So again, rather than trying to guess and check and see where it'd be, just take your radicand, set it greater than or equal to 0. So x has to be greater than or equal to 0. All right. So when we have two radicals, one thing we're looking for is the, kind of intersection. You can see here, x has to be less than 1. Wait a minute, what did I do? X has to be less than 1, but x has to be greater than 3. Well, it doesn't seem like that actually works. So it's either I wrote down the problem wrong, or this one has no solution, or at least there's no domain for f of g of x. Or at least I'm not seeing that. So I didn't work out this problem before, so I didn't look at to see if I had that. But anyways, let's go and work into the composite. So now when we're looking into a composite of two functions, basically plugging one function into the other. So for instance, when we're looking at f of g of x, oops. Okay. So there's two things that we're going to be looking for. One, we're going to be looking for what is the domain of g of x, which is x is greater than 3. And that is going to be the intersection with what is the domain of when we plug in that function. So therefore, when we plug in the square root of x minus 3 into this function, we're going to have over 1 minus x minus 3. So now we basically need to figure out the domain of this value, which, if that has to be x is going to be greater than or equal to 3, now we're going to be looking for the domain of that, which is going to be the intersection, which again, then I would need to go ahead and set that over to an inequality. So this is one thing I just wanted to make sure I'd work out a little bit more before I get into it. But again, the same operation applies, the same rules are not changing. You're still going to have this intersection, but then you're going to also want to go ahead and find, and I just don't have time to go through this and just to verify my answer, but it's going to be the domain of g of x as well as the domain of what is this radicand. So therefore you would square both sides and then go ahead and solve. But I just want to make sure I work on, I want to get to my other questions, but that's going to be at least the idea. And that's the same thing for f of x. So what you're going to want to do is find the domain, or the domain of that is going to be the domain of f of x and the domain of when you plug in f of x, which would look like this. So f of x would be 1 minus square root of 1 minus x. So again, all you would set up in this case would be 1 minus the square